It was sleek, it was loud, and it was impossibly fast. The Concorde wasn't just a plane, it was a flex of engineering ego, a promise that the future wouldn't come on time. It would come early. When it first took flight, the Concorde could cross the Atlantic in under 3.5 hours. That's London to New York before your movie finishes. While other jets chugged along at Mach 0.85, Concorde screamed past the sound barrier at Mach 204, faster than a rifle bullet. If you fired a bullet and launched a Concorde at the same time, by the time the bullet hit the target, Concorde would already be halfway there. But the dream wasn't just speed. It was elegance in motion. It looked like something airbrushed on the side of a spaceship. A long needle nose, swept delta wings, engines tucked tight against the fuselage. It was born from a rare alliance. British and French engineers working together, post-World War II, post-Empire, post-everything. Two nations locked arms and said they will not follow aviation, they'll lead it. And for a while, they did. The world watched a supersonic bird take off. Not a fighter jet, but a commercial airliner. Champagne was poured at 50,000 feet. The seats were leather. The meal was caviar. Celebrities lined up to fly it. Princess Diana, Phil Collins, and even Sting. Phil Collins once famously performed in London and New York on the same day, thanks to Concorde. It was a masterpiece that didn't just defy gravity, it defied expectation. But then comes the mystery, because if Concorde was so perfect, why is it gone? No one builds planes like this anymore. Supersonic flight vanished from commercial aviation like a dream you can't quite remember. One moment, it was the future. The next, it was over. So what happened? Was it the cost? Or the crashes? Or the noise? Did Concorde fly too fast for its own good? Or did it come too early, like a phone with no network? To understand why Concorde failed, we have to go back, not just to the boardrooms and budget sheets, but to the wind tunnels, the engine test stands, and the lonely hangars where it was first imagined. It's about a revolution that fizzled out, a legend that flew faster than anything and still couldn't outrun the world changing underneath it. But first, we start at the very thing that made it a miracle: speed. To understand how the Concorde sliced through the sky like a bullet with wings, you have to abandon everything you know about normal aeroplanes. Because Concorde wasn't designed for comfort. It was designed for speed, first and foremost. Everything else came second, sometimes third. Start with the shape. The Concorde was built to race the wind, slicing through the stratosphere at over 1,350 miles per hour, more than twice the speed of sound. But this wasn't speed for speed's sake. Every inch of its design, every curve, angle, and joint was shaped by one goal: Mach 2. Not because it was easy, but because it was necessary. Let's start at the wings. Concorde's wings weren't like other planes. They didn't curve upward gently or sweep back like a bird gliding. No, they were delta-shaped, sharp, triangular daggers stretching from body to tip. Why, you may ask? Because at supersonic speeds, traditional wings create too much drag. A delta wing keeps airflow stable and attached, even at extreme angles. It trades lift for speed and stability, and it meant Concorde could cruise at 60,000 feet, high above the weather, where air resistance was thin, and the view curved with the earth. But those wings came with a cost: slow speed handling. Delta wings don't like takeoffs or landings, so Concorde needed something else, something no other commercial aircraft had. Most airliners have long, slender wings built for lift and efficiency, but not Concorde. Concorde had a delta wing, a triangle straight out of a fighter jet's playbook. Why, you may ask? Because when you're going Mach 2, the rules of aerodynamics change. Thin, swept-back delta wings reduce drag at supersonic speeds. They also generate lift by creating massive swirling vortices of air above the wing, a trick no conventional plane could survive, let alone master. But that shape comes at a cost. At low speeds, delta wings are awful. They need long runways, steep takeoff angles, and more thrust just to get off the ground. So Concorde needed serious power. Enter the droop nose. At high speeds, Concorde's needle-shaped nose cut through the sky like a spear. But on approach, that same shape blocked the pilot's view. So, engineers made the nose move. Literally. It drooped downward by up to 12.5 degrees during landing, giving pilots a clear sight line to the runway. But Concorde's marvels didn't stop at its clever, pivoting nose. Underneath that slender fuselage roared an even more formidable innovation. The Rolls-Royce Snecma Olympus 593 turbojets were no ordinary engines. They were born from military technology and repurposed for commercial supremacy. Originally developed for bombers, these turbojets were adapted to meet the relentless demands of supersonic passenger travel. Each engine produced over 38,000 pounds of thrust, and with afterburners ignited during takeoff and acceleration, Concorde surged past Mach 2 in minutes. But speed alone wasn't enough. The engines had to be stable, efficient at high altitudes, and precisely tuned to manage shock waves. At takeoff, they roared with afterburners, dumping fuel into the exhaust to create raw, brute speed. You could feel it in your chest. But Concorde wasn't just about power. It was about precision. The same kind of engines you'd find on military aircraft. These weren't high bypass fans like a modern 747. These were straight turbojets, built for raw, unfiltered thrust. And when Concorde hit the afterburners, it ignited extra fuel in the exhaust stream, sending flame and thunder pouring out the back. That fire let Concorde punch through the sound barrier, not ease past it. It didn't sneak into Mach 1. It roared into Mach 2.04. At Mach 2, air behaves differently. It compresses into shockwaves, and if managed wrong, it can tear an aircraft apart. So Concorde used variable air intakes, moving ramps that slowed and shaped incoming air before it reached the engines. It was air sculpting at the molecular level. If the intake geometry was even slightly off, the engine would stall. They called it unstarts. The entire plane would shake like a struck tuning fork. So they engineered around it, every second, at every altitude. And the fuselage was made of aluminum. Titanium would have been stronger, but too expensive. At Mach 2, Concorde's skin heated up to 260 degrees Fahrenheit, so much so that the plane expanded by up to 10 inches mid-flight. That's why you'll see a gap between Concorde's cockpit windows and the frame, so the jet could grow. It wasn't comfortable, it wasn't cheap, but it worked. Every decision, every compromise was about one thing: sustained, controlled, supersonic flight. Not just breaking the sound barrier, but living beyond it. Because Concorde wasn't designed to compete, it was designed to transcend. Now, let's talk altitude. Concorde didn't fly above the weather, it flew above the world. At 60,000 feet, it cruised in the stratosphere, twice as high as a 737. So high, passengers could see the curvature of the Earth. The sky wasn't blue, it was black. And it wasn't just for the view. At that altitude, the air is thin, very thin. Less resistance means less drag. And at Mach 2, Concorde needed every drop of efficiency it could get. Up there, it was flying so fast that it was technically outrunning the Earth's rotation at a local scale. From takeoff to touchdown, time zones folded like napkins. I've been using the word Mach. Let me tell you what it is. Mach is just a fancy way of saying how fast something is going compared to the speed of sound. So, Mach 1 means you're flying at the speed of sound, and Mach 2 means you're going twice as fast as sound. Imagine you clap your hands really loud in a canyon and hear the echo. If you're flying at Mach 1, you're keeping up with that sound. But at Mach 2, you're flying so fast that you'd actually outrun your own echo. Just picture outrunning your shadow. But flying that fast wasn't easy. At Mach 2, every inch of Concorde's skin heated up from friction. The aluminium fuselage would expand 8 to 10 inches during flight. Engineers had to design panels with thermal gaps so nothing warped or cracked mid-air. Even the nose had to adapt. That elegant needle-like beak wasn't just for style. It was called the droop nose. It could tilt down during takeoff and landing to give pilots visibility, then lift back up for supersonic flight to reduce drag. Everything, the shape, the engines, the altitude, was built for one thing: speed. But this speed came at a price. The engines drank fuel like a Formula One car on full throttle. The cabin was cramped, loud, and barely profitable. And sonic booms made overland flights politically impossible. Concorde was a scalpel in a world that wanted butter knives. It was optimized for one thing, and it did that better than anything before or since. But that optimization would soon become its weakness. The plane could cross the Atlantic in just over 3 hours, but that came at a staggering cost. It burnt 25,000 liters of fuel per hour. That's 6 times more than a typical passenger jet. Each round trip from London to New York consumed enough jet fuel to fill a backyard swimming pool. And with fuel prices climbing in the late 70s and early 2000s, that swimming pool started to feel like a small oil spill. Then came the tickets. Flying Concorde wasn't just about getting somewhere faster, it was a status symbol. The average round-trip ticket over $12,000 in today's money. Only CEOs, rock stars, royalty, and the ultra-rich could afford it. And that made it a niche product from the very beginning. A technological marvel, yes, but one with a customer base the size of a luxury yacht club. But Concorde had another problem, a loud one. When Concorde broke the sound barrier, it didn't do it quietly. Every time it crossed Mach 1, it unleashed a sonic boom, a cannon blast of air pressure that could shatter windows, rattle homes, and trigger noise complaints from across the ocean. And this wasn't just a little pop, it was a skyquake. That meant no supersonic flight over land. Concorde was limited to transatlantic routes, mostly between London and New York and Paris and Washington. The rest of the world was off limits. Countries like India, Australia, and even parts of Europe said not to fly it in their airspace. Still, Concorde survived, for a while, until July 25, 2000. Concorde took off from Paris. Just minutes later, it was engulfed in flames. A stray piece of metal on the runway had punctured a tire. Rubber shot up into the wing, rupturing a fuel tank. The plane went down, killing all 113 people on board. It was the first and only fatal accident in Concorde's decades-long history. But the damage was done. The myth of invincibility had shattered. And then, just over a year later, 9/11. Air travel collapsed. Airlines hemorrhaged money. Security changed. Priorities shifted. Suddenly, flying at Mach 2 seemed not just expensive, it seemed indulgent. Maintenance costs for Concorde soared. The airframes were aging. Spare parts were scarce. British Airways and Air France, the only two airlines operating the jet, were quietly preparing for the end. And on October 24, 2003, Concorde made its final commercial flight. It touched down not with a bang, but with a whisper. A mechanical god lowered gently to Earth for the last time. The irony is that Concorde didn't fail because it was a bad plane. It failed because it was too good for a world that wasn't ready for it. It was the Icarus of aviation, daring, brilliant, blazing, and doomed. It was supposed to be the beginning of something, a glimpse of the future, one where cities were just hours apart and the sky wasn't a barrier, it was a shortcut. Concorde made people believe in that future. It made them feel it. Every high-speed prototype that came after owes something to that needle-nosed bird that once outran the Earth's rotation. Because Concorde didn't just push limits, it found them and marked them with its name. It may never fly again, but it will never stop flying in our imaginations. Would you get on a supersonic jet tomorrow if you could? Would you trade comfort for speed, risk for awe? Would you chase the edge of what's possible again? Let us know in the comments. Because while Concorde's time ended, the race to the future never will.